with a function y equals negative a times sine bt. Okay, let me just get a document up here and write that down for you so that it's not just verbal and people can see actually what equation it is that I want to get. Okay, so I'll have to go insert a math formula. Let's go ahead and do that. Bear with me on this. See, if I had that the tablet PC, I wouldn't have had to do this. I could actually write it in, capture the video, and yep, I'm doing a sales job here, so hopefully you appreciate that. My bins here, my tip jar is there. Please drop in some tips so I can fund my purchase here. Okay, so what I want is y equals negative a times sine parenthesis b times t. Okay, and you guys have studied sine waves. You should have done it in algebra 2. I know we definitely did it in pre-calc. We spent a lot of time in trig and pre-calc, and you guys all know that a is the amplitude. And does anybody remember how b is calculated? Does anybody remember how b is calculated? Okay, if you answered that b is equal to what's it going to be? It's going to be 2 times pi over period. Okay, remember period was equal to 2 pi over b, so b is equal to 2 pi over period. So I need to know the period of this function here. So where are we? The period of this function. Okay, so remember, period is really the time that it goes from here to there. Oops, no, till it comes back. Yeah, comes back down again. Okay, so what I've done actually is I've looked at the time for this peak, okay, 2220, and the time of this peak, okay, this one here. Okay, so let's go back to worksheet, and here's 2 other cells that I've created. Here's my period, so please make sure you have all these cells in your worksheet. You're going to be emailing me this worksheet. Okay, so make sure everything is organized as I show you here. Okay, so you got 2 cells, one's labeled the period and the other one's b. And if you look at period, what I've got is it's twice the difference of the 2 times that I have. Okay, so going back again, the 2 times I'm talking about are the time that corresponds to this point and the time that corresponds to this point. So you take the difference of those 2. Okay, take the difference of those 2 and multiply that by 2, which is what you see in the formula here. Okay, that's what you see in the formula there. Okay, all right, so that's my period, and my b is equal to, like you see it at the top, it's 2 times pi divided by my period. Okay, 2 times pi divided by my period. Okay, going back to the sinusoid function that we have here, I'm going to kind of approximate this and say, okay, I think the amplitude, which is your a parameter, okay, go back in here, that's this a here that I'm talking about. Okay, that's this a. Okay, I'm going to say it's about 1.5. Okay, it's not quite 1.5 there, it's 1.5 here, so I'm just going to say it's 1.5. Okay, and go back to your data, and you've got generate a new column, call that the model data. In other words, the data that's going to come out as part of the from the equation that we're going to formulate. Okay, remember again, the model is an equation. It's not parameters, it's not data, it's not just a few numbers, it's an equation. And like I mentioned to you earlier, okay, the model that we are doing is going to be a straight line, and superimposed on that is going to be a sinusoid function. So if you look at my formula in this very first cell, there, if you look at the formula bar, is my equation, and it reads equals negative 1.5 times sine stuff. Okay, and the stuff that you see there is my b parameter that comes right out of there. That's my b parameter. Okay, comes from there. Okay, times time. Remember, time is this column here, so you can see that it's referring to cell C2. That's your time element there, plus my straight line data. So here's my straight line data. See this entry here in the formula sheet? That corresponds to this entry here. Okay, that's my linear data. So here's my formula for 1 point on that modeled data. Again, generate the rest of this column, and we've done this before, so I'm going to go through this very rapidly. Control C this, select the rest of these elements, do a Control V, and paste that formula in there, and you should get model data. Okay, now you've seen a lot of this activity. What do you think the next step should be? What do you think the next step should be? Anybody? Well, if you answered graph that, you're doing well. You understand my, you've got it. You feel the math in your heart. You feel it in your heart. Okay? So graph that. What I'm going to do is I'm going to select this column, again, which is my independent variable, time, along the x-axis, and this model data. Two columns that are not adjoining, so to select them, remember you got to use a control button. Use the chart wizard and graph that, and what I've actually done is I actually graphed the actual data, which was temp M, the actual data, and the model data in the same chart. Whoa, man, that's exciting! Look at that! Look at that! Wow! Wow! So the purple or the hot pink, whatever color you want to call it, is my model. In other words, this equation that I came up with. And the blue data was actually, in the blue line there, was the actual data that was captured by the systems on the GeneSat-1 satellite. Okay? And the data was provided by the Robotic Systems Lab from Santa Clara University. Wow, this is really great. Now you can see it's not perfect. Well, one more time, life is not perfect. If you have a perfect life, tell me how, and you'll be my teacher, and we'll exchange places. Anyway, so this was the modeling activity. I want you to save this data set, and tomorrow we're going to come back and play around with this data set. And tomorrow I'm not going to kind of teach or anything like that. I'm going to kind of let you explore. Let me just kind of plant some seeds in you, okay? The exploration is, how do you define how good this pink data is compared to the blue data? In other words, what's a measure of goodness, okay? Actually, the technical terms that I used, what's the performance metric? What's the performance metric? In other words, how do I say whether this purple curve or hot pink curve is better than some other one? Okay, and can I try and make this even better? So that's what you are going to explore tomorrow. Okay, today I've kind of walked you through this entire modeling activity. Hopefully you've come up to speed on that. You've got your spreadsheet saved. Remember a couple of things that I've told you before. Okay, I'm going to reiterate that. I want your axis labeled. Okay, so here's my temperature axis. Here's my time. Let me kind of scroll this down a little bit so you can see there's my time. My plots are always labeled. My sheets are labeled differently. So here's my data sheet, which is what I started working on. Here's my worksheet where I was doing some scratch work. Here's my first temperature M graph that I just graphed. Here's my line that I kind of generated. My temperature with no linear trend in it, and so on. So I want these sheets to be labeled as you see them here. Okay. Okay, make sure you save this with the names of the individual students, the first names. Okay, separate them with an underscore. Tomorrow you're going to do some exploration, and then after the exploration you're going to send the files in to me, and that's how we're going to grade this. Okay, well, hopefully you've got everything down now. All right, goodbye. I had fun. I hope you did too. See ya.